Hello everyone. Today we are going to solve the seventh problem of AtCoder beginner contest 308, which is minimum XOR pair query. So we are given two queries. The queries could be of three types. First one is 1 comma x, that means we have to write x in the blackboard. 2 comma x, that means we have to remove exactly 1x from the blackboard. And 3 means that we have to find the minimum XOR between any two pair of elements written in the blackboard. This queries are sequential, that means the first query will impact the second query and so on. So I'm not able to solve the problem during the contest, but I have solved this after the contest. So I have solved this problem using try. So when we are solving XOR based problem, one thing came to my mind is obviously how we can solve this problem using try, and here insertion and deletion are also given. So using try to insert and delete an element from the array is easy. That's why I have thought about solving this problem using try. So what is the structure of our try? So the structure of our try is nothing but the first element will point to the next node. So let's say this is our try pointer, try struct. The second first value is the next node, try next node. This could be of two types, because if we get 0 and if we get 1, and the second value is count, integer, let's say count. This is the or format of the try. Okay, so let's say this is our root node. The root node will contain two pointers for 0 and for 1. Okay, and it will also contain one value, count, the number of elements in the try. So so if we insert all the elements in the try, let's say n elements, then the count of the root will be n. Now let's say this is again another pointer. This will have 0 and 1. The count will be, let's say, x here. Let's say count is x here. Then the count should obviously be, let's say this is p0 and this is p1. Then count should obviously be n minus x here. So the total count of the 0th pointer and 1 pointer will be equals to the sum of this p0 and p1 will be equals to the value of root. Okay, I hope you got it. Now we can handle this try using 2D array, or here we are using 3D array. So that's the thing I will explain in the when I will explain the code. Now let's go into the solution approach, that how we will solve this problem. So for the first thing is quite straightforward. We will insert the first element in the try. Let's say this is 1 2. So first we'll insert 2 in the try. So let's copy this thing, copy and write here. Okay, so first we'll insert okay, let's write again. Okay, so first we will insert 2 in the array, 2 in the try. Okay, 2 is inserted in the try. Now again we will insert 10 in the try. So now two elements are inserted in the try. Now we will find what is the minimum element, minimum XOR of two elements. The minimum XOR of two elements is 8. 2 XOR 8 is 2 XOR 10 is 8. So we will also keep one set of tuples of 3 elements, set of triplets you can say. So we will insert 8 comma 2 comma 10 in the set. Okay, and we will also maintain another map of sets, you can say. Let's say this is D. So D2 will contain 8 comma 10. This is an array. This is a set, you can say. This is a set of array elements. So we can write it as this is a set of pairs 8 comma 10, and D10 will contain 2 comma 10. Okay, this is a set. Okay, this is a set. This two sets we are maintaining. One is a common set, and the second one is a map of the integer to set. Okay, integer to set. D10 will contain nothing but 8 comma 2. I hope you got it. This is the first operation. When we insert the array, we will insert get the minimum element. We will insert in S. We will insert in D of X and D of, let's say our minimum value is, let's say, min XOR. Okay, so what we will do, so let me write the whole thing again. So let's say we are inserting some value X in the try. Okay, so then after before inserting it into the try, let's say before inserting X into the try, we will find the minimum element. So let's say that is min XOR. Okay, now what we will do, we will insert into S, we will insert into X min XOR. let's say mx comma x comma x or mx. So this array, this set is containing first element will be the minimum XOR, the next two elements is the elements involving in the XOR. Okay, let's say x or mx. This will be inserted in the x, and for dx we'll insert mx comma x or mx, and for similarly for d of mx, let me write it here. For d of mx we'll insert uh, mx, sorry, not mx, it will be mx xor x. We will insert mx comma x. Okay, so it is nothing but the elements are nothing but in the array. So S will contain what? S will contain all the triplet of all the means or elements. Okay, and D of X will contain all the elements involving in the minimum element involving X. Okay, I hope you got it. Now let's say we are doing the second kind of operation here. What is the second kind of operation? Second kind of operation is that we are removing X. Okay, so when we are removing x, we will iterate over this dx array because these elements are involving x while calculating their minimum sort. So what will we do? We will remove this array, this element from d, and similarly from s. Okay, we remove the from dx, d mx or x and s, and similarly what we will find? We will find the let's say our new elements, let's say p. P is nothing but this mx dot x. Okay, p is nothing but mx dot x. We will delete this pair from d of p. We will remove this pair from d of p, this pair, and we will remove this triplet from s. Similarly, we will remove this pair from d of x also. And at the end, after doing that, we will delete this x from trie. That is the first operation. Delete this x from trie. Uh, then finding the minimum value for mx dot x again and inserting into the trie again. Okay, I hope you got it. And at the end, what will we do for third kind of operation? For third kind of operation, we'll just print the first element of the set. So I know this might seem confusing, but when we will go through the code, you might understand it better. Okay, so let's jump into the code here. So here I am solving this using a three-dimensional array, but you can use some kind of pointer-based array also. So similar to this type of structure. Okay, but here I am using 3D array, but this insert, search and delete is quite straightforward, so I am not explaining it into deep. You can find that inserting an element into the array, deleting an element from the trie, and the third kind of operation is finding minimum element from the trie for a given value. This three type of operation you can find it in CP algorithms or gigs for gigs, so I am not explaining this thing now. What I am explaining is that I am taking two type of sets. I have already told. The sets are, one is this map of LL for LL is for finding the count of the elements. Let's say how many times X appear or down how many times Y appears. And this map of LL comma set of array of length 2 is nothing but this set, this map. I have already told this D map, and S is nothing but for containing all the minimums or involving different elements. Okay, that's I have already explained here. Okay, now let's jump into the code. Now when this is the first type of operation, what we will do, we will insert increment the value of count x and increment the value of c. C is the total number of elements present in the blackboard. Now if c is equals to 1, okay, if c equals to 0, that means that there are no elements in the blackboard, then it is there is no point finding the minimums or for this x. So we are doing this operation only when there is at least one element present in the blackboard. Okay, so we are finding the minimums or for x, that is p is equals to min XOR here, and we are finding px. Px is min XOR x. Okay, that is p XOR x. Now we will insert dx dot insert p comma px and d of px dot insert p comma x, that I have already explained here, that we will insert this thing and this thing. Okay, I hope you got it. Now similarly we will insert this min XOR in the s set. Okay, Now we will increment the value of c and insert the element in the trie. Insert function is for this trie. Okay, this insert function is for this trie. Now the deletion is some kind of tricky. Okay, this deletion operation is kind of tricky in my implementation. So what we will do, we will just decrement the value of count of x, and we will decrement the value of total number of elements present in the blackboard, and we will delete this element from the trie. Okay, now there is catch. There are two conditions. One is count of x is 0 and count of x is 1. So why it is happening? If all the elements of the blackboard are distinct, okay, if all the elements of the blackboard are distinct, we don't have to do this operation. But as there could be two x's, okay, there could be two x, so we will be doing this operation, removing from x or dx or dmx or x, only when there are no elements present in the blackboard when we are deleting x. Okay, I hope you got it. So when count of x is equals to 0 only, then only we are doing this, removing s from dx and d of mx or x. Okay, now what we will do, we will remove from s. This part is for removing from x and this part is for removing from px. Okay, I hope you got it. Now if the count of px is already 1, px is nothing but means or xor x, I have already told you. We'll delete that from trie, because let's say we will find, I have told you, we will find again what is the min-zor for this element after deleting x. But if we don't delete it from trie, then px is already present in trie, then our minimum zor will be px or px equals to 0. So we will remove this element from trie, and again we will insert the same thing. Same thing here is happening. Okay, this part is similar for the insert operation, you can see. Okay, so this is for type 2, and count of x is 0. But if count of x is 1, count of x is 1 means that there are two x present in the blackboard and we are deleting one x, then there will be one element present in the set s 0 comma x comma x. We have to delete this pair. Okay, we have to delete this pair, so we will be deleting this pair from the set s. Similarly we will remove from dx. I hope you got it. Now, for the third kind of operation, we will print all the element in the set S. Sorry, the first element in the set S. Now, this approach might seem quite implementation heavy or hard for you. In that case, you can find the editorial. I have not seen what the editorial is given. You can find in this. There could be some discussion blog on code forces. You can write the solutions from there, or you can rewatch the video again. I will give the link of the code in the description box. If you have any doubt in any part of the video, you can always ask me in the comment section. I will try to reply each and every comment. So if you find this video helpful, please like the video and subscribe to my channel. Thank you.